The last set of problems here for 0.1, take a look at the function notation. Obviously, got the algebraic side of this, but we also need to make sure that throughout this course, we're focused on the aspect of this where it could play out in terms of something situationally happening in a real life scenario. So, and how do we display that, whether it be a function, later on a graph, et cetera, et cetera. So, in this last problem, we're going to go ahead and interpret. So there's not really any math work to be done, not a huge amount at least, but we're going to interpret each of the following statements in the context of this scenario. Let n of t represent the number of people in line at a barbecue food truck t hours after the food truck opens. So a lot going on there, kind of a wordy statement, but the focus here is the fact that we have t and we have n of t, right? So when I'm focused on these situations here, we got to understand that, t is taking the place of x. That's what we're looking for in the parentheses all the time. So those numbers right there are always referencing the hours after the food truck opens, right? So if a food truck opens up at 10 o'clock, a t value of 1 would be 11 o'clock. And then n of t, of course, is this concept here, whether it be the whole function notation or the number by itself on the other side of that. So let's go ahead and talk about this. The first thing we see is n of 1 is equal to 11. And of course, if I had to write that out as a point, I would write that out as 1 comma 11. Well, in the context of this problem, what does that mean? What it means is that the food truck's been open for 1 hour, then there are 11 people waiting in line for it. Business must be good. So all I'm going to do here is kind of write a sentence. There's not, again, really any math work to be done here. 1 hour after open, 11 people waiting in line. I'm going to go ahead and abbreviate people, PPL. So hopefully you have enough room on your page to do this a couple different times. That's the general idea here. We have a number specifically on the other side. Then we move over here, and then I start seeing these other symbols involved. N of 0 is equal to n of 3. Now we know that the 0 and the 3 are time amounts, but we don't have a specific y value like we had on 11 on the other problem. What does that mean? The only thing that's telling us here is that we know information about at 0 hours, or when it opens, and 3 hours. And they must be, wait for it, the same because of that equal sign. So we'll go ahead and mention that. At open, which we know is 0 hours. Come on, there we go. Is equal to 3 hours after open. I don't know how many people are there. It could be 0 people because it just opened. It could be a lot of people because they were waiting in line for the doors to open up type thing. But irregardless of that, whatever the case may be, the y values for that would be the same exact thing. So we'd have like a 0 y and a 3 y, whatever that may be. But we know it's an equal amount. Same thing goes for the one right next door to it. We see this greater than symbol, the fatter parts to the left. And what that means is, again, we don't know any information about the y value, but I certainly know information about the x value, the domain, the input, the t in this situation. And what this says here is that there will actually be more people in line at 4 hours than there is at 6 hours. So more people in line at 4 hours than at 6 hours. And I might look at that and think that's kind of weird because, well, what are you talking about? The number 6 is greater than 4. That doesn't make any sense. But again, we're talking about a location on a graph, right? And we don't know the Y values here, but we do know that there's more people waiting in line 4 hours after the open than 6 hours after the open. Maybe it's a lunchtime or a dinner time or something like that. Who knows? So again, super important throughout this class to be able to interpret function notation and the things that we see from a graph and from words in terms of application.